Welcome back everyone to the second part of our introduction to Unreal Engine Blueprint. This time we're focusing on blueprint communication and classes. All right, next up, blueprint communication. So this is the third person character. And as you can see, what a mess. There's so much going on here, and usually you don't want that to happen to you. So there are a couple of things you can do to keep things more simple. And one of them is by separating things out into different blueprints. For example, on my character, I have this component AI loadout, and the only thing it's responsible for is dictating different AI equipment and behavior. So the player character actually doesn't have to have it, but it's just disabled for that. And this way, I don't have all the logic that's associated with the AI in the general character, because as you can see, there's already enough going on. Now that you have two different blueprints that have to work together, though, they have to talk to each other in a way. They have to communicate. And there are a couple ways you can do this. First, there's blueprint interfaces. Then there's calling, and then there's event dispatchers. My preferred method of blueprint communication is using blueprint interfaces, but really all of these three methods have their own scenario where they are most effective. Technically, you can do almost everything with each of them, more or less, but they have their own preferred use cases. So let's start with interfaces. Blueprint interfaces are separate files in your content browser, and they have a collection of functions. So one of the interfaces that I'm using is BI Attack, and as the name suggests, it has a couple of functions that are responsible for sending information regarding attacking. This is for communication between the character blueprint and the animation blueprint, or between different characters. So I have a blueprint, and for an interface to work, you have to add it to the class. So if you go to class settings and interfaces, you get a list of all your blueprint interfaces, and you can just add one. So now I've added this interface, and this allows me to access a couple of new functions. So now I can send messages using this interface. For example, I could send a light attack message to someone. Someone is supposed to start a light attack. And here, as I mentioned earlier, we have to have an actor object reference. This is the target. And it's going to send this message to this actor. Now let's say that actor is my third person character. If I quickly search for the light attack, you can see the light attack is being referenced here. Now actually this is not, this is also sending light attack messages. It's not listening for a light attack. So if someone would send, if our test blueprint sends this light attack to the character, this message, the character will just ignore it. In order for the character to do something when it receives this message, what we have to do is add an event, right? Event light attack. Now, if this test blueprint sends this message to the character will do whatever we connect up here. So the best thing about interfaces is exactly that. if a message gets sent to a blueprint and the blueprint doesn't know what to do with it, it will just do nothing. That's really good, because in case of the other two methods of communication between blueprints, casting and event dispatchers, if they send something and the blueprint that's receiving it doesn't know what to do with it, that results in an error. So blueprint interfaces are really useful for avoiding errors, but of course not for every type of communication they are ideal. So now we know how to send messages, right, from one blueprint to another blueprint. So the next type of blueprint communication is casting. And inside this mess here, you can see there's some casting happening. So the good thing about casting is that it's very good if you want to do quick adjustments and you know exactly what your target is. So in this example, you can see the target is third-person character. Again, you need, like for the interface message, you need an object reference. Who are you casting this to? And then, as whoever you're casting something to, you can execute some logic. If you drag out a pin from your object reference and you type in cast, you can see a list with all types of classes. And this is where some of the pitfalls lie with casting. So if I pick the wrong class here, it's not going to work, right? If I pick vehicle anim instance, for example, and I get the anim instance from this mesh, and it's actually not of the class, like, because my character is not a vehicle, it does not have the vehicle anim instance. If I cast there, even though I can compile it, everything's fine. If I execute this, it's not going to work. And you can see there's already a pin for cast failed here, because this is very likely to happen. So it's already validating this. And in the event of a fail, usually you will do nothing. But the good thing is, as whatever you're casting to, you have access to all of its information. Now, the good thing about casting is that as the object, basically when you're casting to another class, you can then execute logic as that character, class, actor, whatever you're casting to. And you have access to all of its information. So for example, I'm in my third-person character right now, and I want to get some information from the third-person anim BP class. So this is my animation blueprint that has all the information about animations that my character blueprint doesn't know about, but I need this information for something. Now, by casting to that class, I have access to all of it. For example, I have some information about the character's animations in here. I have some variables, like, for example, this footstep sound or attack sound, or those things only exist in my animation blueprint, and now I can access them from inside my third-person character blueprint and do something to them. I could manipulate them. I could set a variable in my character blueprint so I can transfer this information from one blueprint to another. So this is really, really powerful. One of the problems is that I am executing this logic basically in another blueprint. So let's say I have a bug in that other blueprint, something with its behavior isn't right, and I'm looking in the blueprint and I just can't find what the problem is. And the problem might be happening inside my third-person character blueprint here, because I'm casting to this other class and executing some logic. So this makes things a little bit messier. With the blueprint interface, the interface cannot execute any logic as another blueprint, right? It can only send this message, but then whoever receives the message will do something. In this case, I can do something as that other class. So it's really powerful, but also really dangerous because you can mess up a lot of stuff accidentally. Another issue is that you need to know the class. For example, for this anim instance, I need to know I'm casting to this third person anim BP. But if the thing that I'm referencing actually is not the third person anim BP, like if this object has a different class, this cast is not going to work and it's basically going to do nothing. So that's another thing to watch out for. The last type of blueprint communication is event dispatchers. So the way that these work is quite simple. They work by binding events together. So I have another blueprint, and let's say you're casting to a blueprint, or somehow you get a reference to another blueprint, and you have an event that's happening there. In this case, I'm referencing my customization menu, and I have a button that executes some functionality. In this case, the button itself actually has no functionality, but I am binding an event to the event of the button being pressed. So in this case, this event is for a button being pressed. And I'm binding this event to that other event in the other blueprint. So what this does is basically whenever this other event is being fired, this event is also being fired, but this other event is in another blueprint. So this is really good for things that might happen frequently, events that happen a lot of times. Next up, we have blueprint classes. So when you create a new blueprint, you have a couple of options. Basically, those up here, you have the most common options. Most of the time you will be using those. But if you scroll down here, you will basically have every already existing blueprint class in your project. So most commonly used classes are actor, pawn character, and actor component, scene component, and object. So what's the difference between all of these? You can see there's a small description here. If you go on the question mark, you can look at the full documentation. I'll just give you the quick and dirty breakdown. So the actor has a lot of functionality, and usually you want to use an actor for anything that can be placed in the world by itself. Any kind of object that you can interact with, that should be an actor. The next one that you're usually going to be using is an actor component. So this is something that can be added to an actor. It has some functionality. It cannot exist on its own, right? It's always attached to an actor. And it also doesn't really have a place in the world. It has some functionality, but no 3D representation. That's what a scene component is for. So a scene component is basically an actor component, but it can have collisions and things that exist in the world, but again, needs to be attached to an actor. So this could be, for example, I have a sword, I'm holding the sword in my hand, so this could be a scene component that's attached to my character that has that sword. And if I switch out the sword for something else, it's just something that I need to manage in the scene component. And my actor, who might be my character holding the sword, doesn't have to worry about that. Speaking of characters, so you have the character. This one already includes walking, simple navigation, can be very useful for characters like the name says. The next important class is the object. So the object is, as you can see if you scroll down here, all of these are children of the object. The U object to be specific, because it's Unreal, it's called a U object. And the U object is the most basic class of a blueprint. If you create a U object, you open it, it has nothing, right? It's not ticking, no begin play, no construction script, super simple. So for example, I have my character equipment, right? Like the sword, for example, and the sword is a U object because all it has is some information and that's it. It doesn't really do anything itself except interact with some blueprint interfaces where it's sending and receiving information, and that's it. That's all it ever needs to do. So for this type of thing, the U object is perfect. Now another thing about classes is that classes can have parents and children. So as I just mentioned when I was about to create a new blueprint class, right? All of the classes are children of the U object. And that means that, for example, if I was to change something in the U object class, it would also update all this information in all of its children. If I were to add a variable to the U object class, then all of these other classes now would have that variable as well. So this is super useful. For example, I have an equipment U object class. If I open it, you can see there's just a bunch of variables. And basically those are things that every piece of equipment has, right? An icon, state, level, and a mesh. Every item has these. Next up, if I go down the hierarchy, I have a class for armor. And this class is a child of the equipment class, which means if I open this up, I have a couple of variables here, right? So it kind of looks like it's its own thing, but what I can also do is set the icon, right? And the icon is something that I have in my equipment here. So all of these variables, even though they are not listed here, they still exist in all of these children and they can be modified as well. So this is all the functionality that I have for my armor, right? This is unique to the armor, and I created a different child blueprint because the armor and the weapon are sending different stats, so they have different functionality. But then, of course, all the armors are basically the same. They all just have different stats, right? But functionality-wise, they're all supposed to do the same thing. So if I open those up, you can see all there is variables that I adjusted. But if I go to the full blueprint editor, there's nothing, because nothing is different from the parent blueprint, which is the armor equipment. The only thing that's different is the values that I changed for each different armor piece. It has different mesh, right? Different values. As I mentioned earlier, in regards to organization, it's good to keep it simple and simplify things as much as you can. One of the ways that I mentioned is by separating logic out into different blueprints that you then attach to each other. Another way of simplifying things is by using functions inside a blueprint. So a function like this one, for example, is basically just a bundle of logic that you combine together, and whenever you call that function, right, all the logic that's in there will be executed. You have inputs and outputs, In this case, this function doesn't really have any inputs or outputs, but you can add any that you want for any information that you want to modify. Really, the main reason for functions to exist is to simplify things. Technically, you don't need to create any functions at all. You can do almost anything without functions, but then everything will be a horrible mess like this. And this is actually already using a lot of functions. If I go over here, you can see there's already a bunch of functions that I'm using, and still this looks very complicated, and it's not even all the logic that is being hidden inside of functions is not even visible. So actually it's even more complicated. Inside of a function, you can execute almost any functionality that you can execute outside of a function, with a couple of notable exceptions. Mainly anything that is related to time. So delays and timelines don't work inside of functions. Here I'm in my main event graph, and I can just add a delay, right? No problem. But if I am inside of a function, I try to create a delay. You can see it doesn't let me create a delay. And that's because everything that happens in a function has to happen instantaneously, basically. Now, what if you have something some type of functionality that you want to reuse a lot? You don't want to have to copy paste it all over the place in your graph, right? That would be super annoying just because there's like a delay somewhere. So for that, there are macros. And macros basically are very similar to functions, as in that they encapsulate functionality inside of them. But functions have some additional features. You can call functions easily from other blueprints, whereas with macros, you can't really do that. And really, a macro is just an encapsulation of functionality in your graph. And when you're compiling your blueprint, basically the macro will be replaced by that full functionality that will just be copy pasted from the macro into your graph. Functions are a little bit different, but really the only drawback that they have is the time delay functionality that you cannot use inside of a function. So usually it's best if you use a function whenever possible, but if you need to do something that you cannot do inside a function, then of course you can go ahead and use a macro. Now, a couple notes on organization and programming principles. These are basically the principles that I use, and as it goes for organization, you can see it's maybe not the best. And that's because in the beginning, I wasn't really sure what I was doing. You can see this is like a horrible tangled mess. It's very hard to read and not really nice. So ideally, you should avoid ending up in this situation if possible. But what I'm trying to say is that if this happens to you, it's not the end of the world. So regarding principles, for me, really, it's number one, get it to work, right? Doesn't matter if it doesn't work, like if you build the nicest blueprint ever, it's useless. It has to work. Now, second is keep it simple, right? You want to keep your logic as simple as possible. That's just good for performance and usually good for your sanity as well. And the third one is keep it nice, keep it cleaned up. You can see all of this functionality. If I play the game right, it works. So I have fulfilled my first principle. I got it to work. It's also relatively simple. I have done my best to simplify things wherever possible, logically speaking, right? Not necessarily visually, because there should be more encapsulated in functions. because the third principle, which is the lowest priority, is right, keep it nice. And you can see I've not been keeping it very nice. And to be honest, this is kind of if you're learning Unreal while you're building something, which is the way I would recommend it because it's the most fun. If you are going to be organizing stuff all the time, you're going to be wasting a lot of time because chances are you don't really know how to do something properly the first time you do it. So you will have to rework things. And if you organize them nicely, of course, if you rework them later, it will be easier for you to understand what's happening there. So that's good. But you have to spend that time again reorganizing it after you changed it. And if you keep changing things, you're gonna be spending a lot of time reorganizing stuff. So usually my way of approaching things is organizing things after I am certain that I'm not going to change them anymore, or at least not drastically. But really, you can handle this whatever way you want. This is just my philosophy. Another thing regarding naming, my naming convention is all over the place. I've been trying to do my best regarding content, but it's not always super consistent. And especially if you're not working by yourself, you have to have a consistent naming convention. For me, I can get away with all this stuff because it's just me. I have to understand myself, and usually I'm pretty good at that. If someone else had to understand all of this without me explaining it, it probably would be very, very hard. So especially if you're working in a team, you have to have a consistent naming convention. And for that, I recommend this page, the UE4 style guide. It has naming conventions for pretty much anything from like any file type that exists inside Unreal. There's something there. So if you all just stick to that, it's going to make your life a lot easier.